Hello class, today we are going to talk about properties of logarithms. These are a lot like the properties of exponents, when stuff gets flipped around a bit. So what we have here is the product property, the quotient property, and the power property. Now the product property says if you have log base b of m times n, this is going to equal log base b of m plus log base b of n. So for example, if you had log base 5 of 2 times 3, then that would equal log base 5 of 2 plus log base 5 of 3. Right? Quotient property, exact opposite. So log base b of m divided by n equals log base b of m minus log base b of n. So log base 5 of 2 divided by 3, for example, would be log base 5 of 2 minus log base 5 of 3. Power property, log base b of m raised to the n equals n times log base b of m. So for example, if you had log base 5 of 3 squared, this would equal 2 times log base 5 of 3. All right? And what we can do with this is if we know what the logarithm of m is and the logarithm of n is, we can use it to find some other things. So if you know two logarithms, you can use them to find some other logarithms. All right? So for example, we know that log base 2 of 3 is approximately 1.585. And we know that log base 2 of 7 is approximately 2.807. So now we're going to evaluate these. So on A, we have log base 2 of 3/7. Notice this is very important. The bases are all the same. They all had to have that same base. So we couldn't use log base 5 or something to solve this. We have to use log base 2 because these are 2. So we have 3 and 7, and they're being divided. So this is the quotient property. And this one's fairly obvious that that's what we're doing. So the quotient property says this is going to be log base 2 of 3 on numerator minus log base 2 of 7, which is the denominator. Now I actually know what these equal, right? Because log base 2 of 3 is about 1.585, so I can substitute that in. Log base 2 of 7 is about 2.807, so I can substitute that in. And that's what I'm going to do. I'm just going to substitute these values in for the logarithms, and then we can just subtract them. And that gives us negative 1.222, approximately. B is a little bit trickier, but it's not much. We have 21. There's no 3 or 7. I don't see that. However, how can we use 3 and 7? How can we use these arguments to get an argument of 21? Well, 21, that's 3 times 7, right? So we're going to rewrite it as 3 times 7. And this, they're being multiplied, this is the product property. So what we're going to have is log base 2 of 3 plus log base 2 of 7. Again, I know what those are. So I'm going to take these values, plug them in, substitute those in, and then add them up. And stick that in the calculator, add it up. There it is. 4.392. Now for C, how can we use 3 and 7 to come up with our argument of 49? Well, 49 is 7 squared, so that's not going to use the 3, just going to use the 7. So we're going to rewrite this as log base 2 of 7 squared, and this is going to be the power property. So what happens here is our exponent moves to the front of the term, and we have 2 times log base 2 of 7. All right? So 2 times 2.807. Substituting that value from right there, which gives me about 5.614. All right. So what I want y'all to do is to evaluate these logarithms, use your properties, pause the video, work these out, then come back and check your answers. All right, let's see how you did. Okay, so there's your answers. Hopefully that's what you got. If not, let's check out, see what we need to do with this. So log base 6 of 5/8. We have log base 6 of 5. We have log base 6 of 8. So we're dividing the 5 and the 8. So we're going to use the quotient property, and we are going to subtract the logarithm of log base 6 of 5 and log base 6 of 8. Substitute in the numbers we know, subtract them out, and we have negative 0.263. Alright, so next we have log base 6 of 40. How can we come up with 40 using 5 and 8? Well, 40 is 5 times 8, so we're going to rewrite it like that, 5 times 8. And so this is going to be the product property. So log base 6 of 5 plus log base 6 of 8. Substitute in the numbers that we know for the logarithms that we know, and add them up. And we get 2.059. Next one, log base 6 of 64. How can we use 5 and 8 to come up with an argument of 64? Well, 64 is 8 squared, so we're not going to use the 5 on this one. We're just going to use 8 squared. So 8 squared, this is the power property. The 2 comes in front of the term. So we have 2 times log base 6 of 8. Substitute in the log base 6 of 8. And we have 2.322. Number 4, we need to get 125 using 5 and 8. Well, 125 is 5 cubed, so we're going to rewrite this as 5 cubed. And we're going to use the power property just like we did on number 3. So the exponent comes to the front of the term. 3 times log base 6 of 5, which I know to be 0.898, so 3 times that, gives me 2.694. Right? So that's how you use those properties to solve for values, to evaluate logarithms that you don't have. All right? Go to the next page. There it is. Okay. So now what we're going to do is use our properties to expand a logarithm. What it means when it says to expand a logarithm, that means to take this one term and break it apart, stretch it out into as many terms as you can. All right? And what we really want here is nothing being divided by anything and no multiplication, no exponents. All right, in our arguments. We want each logarithm to just have one thing in the argument. All right. So what we're going to do with this is order of operations backwards. It's kind of like solving something, getting something up by itself, sort of. So first thing we're going to do is undo the division. All right. So if we're going to do that, that would be the quotient property. So we're going to need to subtract. So we're going to have natural log of 5x to the 7th minus natural log of y. All right, takes care of the division. Next, we're going to take this and break this one apart. Don't have to do anything else there. That's just got one value there. So we're going to take these and break these apart. So first, we're going to split the 5 off from the x to the 7th. So this is multiplication. So we're going to use the product property. So this is natural log of 5 plus the natural log of x to the 7th. All right, so that one is good. It's just got one number there. This one, we still got two things in the argument. We've got an x and we've got a 7, so we're going to break those up. This is an exponent, so we're going to use the power property. Power property, the exponent comes to the front of the term. Notice the 7 just goes into the front of this one term. It does not go to the front of the entire expression. All right? It just goes right here in the term that it's in. Okay? And this is how you expand a logarithm. All right. What we're going to do now is the exact opposite. We're going to condense a logarithm. Here they've got it all spread out. We want to put it all back into one thing. All right. Again, we're going to use order of operation. We're actually going to go in order this time. So first thing we want to take care of is multiplication. Right. So 3 times common log of 2. Well, that is the power property, so we can rewrite that as logarithm common log of 2 cubed. All right. Next, we're going to take care of addition and subtraction. Addition is going to come first because it's in the order left to right. So we have common log of 9 plus common log of 2 cubed, and that's addition, so this is going to be the product property, 9 times 2 cubed. All right. Multiply your arguments. Next, we're going to take care of the subtraction. Well, subtraction is the same as dividing the arguments. So we have common log of 9 times 2 cubed divided by 3. And this still can be simplified some more, so we're going to stick that in a calculator, work it out, and we end up with common log of 24. All right. So all of this is just that right there. All right. Makes it a lot nicer. So what I need you to do is pause the video, work out these 4, expand the top 2, condense the bottom 2, Then come back and check your work. All right, let's see how you did. So this is what you should have gotten. If you did, good job. You can skip forward a couple of seconds there. If not, we'll go over and see how to fix it. All right, so number 5, first we need to break up this right here, multiplication, so product property. So log base 6 of 3 plus log base 6 of x to the 4th. Now we need to split up these exponents here, this x to the 4th, and the power comes to the front. All right, remember, it just goes to the front of that one term, not to the front of the whole thing. All right. Number 6, first we're going to split up this division, so that's the quotient properties. That's going to be subtracting. All right, so we're going to subtract our logarithm, so natural log of 5 minus natural log of 12x. Now we're going to split up this multiplication, so that's product property, so we need to add them, add the logarithms. Now, one thing to pay attention to, and this is where probably a lot of you all messed up, you probably got a plus right there. We're subtracting this entire natural log of 12x. So this is still being subtracted, so we've got to put in parentheses and then distribute that negative 1 in. And that's what changes this positive to a negative right there. Number 7, we're condensing. This one's pretty obvious. That's just the quotient properties, so we just have x divided by 9. Number 8, a bit more complicated, so let's take a look at number 8. And I took this and simplified it step by step by step. So first we're going to take care of the multiplication, because multiplication comes first. So this becomes natural log of 3 cubed, which I went ahead and simplified as 27. So now I have natural log of 4 plus natural log of 27 minus natural log of 12. Well, let's take care of the plus first, because it comes first in order. So we are adding the logarithms, so we multiply the arguments. So 4 times 27, which is 108. And now we have the subtraction, and if we're subtracting the logarithms, we divide the arguments. So 108 divided by 12, which is natural log of 9. All right? Okay. Last thing we're going to talk about, change of base formula. What this is used for is to change log base 5 into log base 7 or log base 23, or more useful, log base 10 or log base E. And the way this works, you have log base C of A equals logarithm base B of A divided by log base B of C. And the reason this is useful is we can change this into log base 10, which is common log of A over common log of C, common log of the argument over common log of the base, or natural log of the argument over natural log of the base. And we can use this because most scientific calculators will solve common log and natural log. Won't solve base 5, but they will solve base 10. And so we can use this to change some base that we can't solve into a base that we can. All right? So here we're going to evaluate log base 3 of 8 using common logarithms. So we're just going to rewrite this, common log of 8 divided by common log of 3, and then we just stick it in our calculator. And just so you see, this works whether you use common log or whether you use natural log. Either one, it's going to give you the same answer. So it doesn't matter which one you use. All right. Here it is using natural logarithms, log base 6 of 24. We change that to natural log of 24, natural log of the argument, over natural log of the base. Type that in your calculator and you get 1.774. Right? So now, what I want you to do is to pause the video, work these out. You can use common log or natural log, doesn't matter, and then come back and check your work. All right, let's see how you did. All right, so there are the answers. That's what you should have gotten. If not, here's how you set them up. So number 9, I used common log of the argument, 8, divided by common log of the base, 5. And you just type that in your calculator and you get that. Number 10, I used natural log, because why not? Natural log of the argument over natural log of the base, and that should be in 5, not an 8, not a 5. So that's a typo. Oops, that's an 8. Just looks like a 5. All right, number 11. We have log base 26 of 9 is, again, yeah, so that's right, argument over the base. And number 12, log base 12 of 30 is common log of 30 over common log of 12. And I hope this helped. I'll see you next time.